Dear students, welcome to our fifth video for the loop. So what is a loop? Loop is a block of statements which we will need to execute many times, more than one times. So for that, we don't write those executions, those statements n number of times, many times. In place of that, we use a loop statement, and there are two types of loops. One is the for loop, the other one it is the while loop. So in this video, we'll discuss about the loop. Now, let's move to the session.
Now first let us look at the syntax of the for using a small program for loop. Here we will write a program for the table of a number. So let n is equal to say 5 or 4. We'll have to write table of the 4. So for I in range, it will start with the 1. Our table starts with the 1, and here we'll have to write it 11 as our loop will start with the 1, but it will this 11, it will go 1 less than this number. So it is, if we have written it 11, it will go up to 10. As our table, it is for multiplication of 1 to 10. So now p is equal to n into I and print p. So it will print the table of the number range. So it is 4, 8, 12 up to 40. So how it is working? For I, it will start with the 1, then it will multiply. It will start with the 1 and it will check whether this I is less than this number or not. Less than, not equals to, up to. It should be less than this. So I in range 1 to 11 means it will be 1 to 10. N is equal to 4, 1 into 4, 1, n is equal to 4, 4 into 1, that is 4. So P, printing it pre, it is 4. Then it will go to increase the I it will become 2 automatically, and it is within the range, that is 1 2 but less than 11. So 4 into 2, it will be 8, it will print 8, so it has printed 8. Next, it will again increase I, it will be 3, and it is less than 11, so it is true. And 4 into 3, 12, it is 12. Next, in this way, it will go up to say 9, I is equal to 9, the condition it is true. 4 into 9, that is 36, so it has printed 36. Then I will increase by 1, that it will be 10, and 4 into 10 is equal to 40, print 40, so it is printed 40. Next, again I will increase and it will become 11, and as it has become 11, so it will terminate, means the condition it is become false, as I have told that the I should be less than this number, it should not be equals to this number. So as now it has become equals to or it is greater than this, so the condition it will false and it will terminate, and we will get this output. Now we will try another program using this for loop, where we will print the sum of all natural numbers up to the number n is given. Say n7. Then to store the sum, we'll take another variable. Let it be s. So s is equal to 0. Initially the container is 0. S. Again for I in range 1, and it will be n plus 1, because we need to find the sum of first n natural numbers. So here we'll have to give it n plus 1, so that the for loop will execute up to n, and then it is colon. Now s is equal to s plus I, and finally after this we'll print the print s, and it will give the sum. Now let's run it. It is 28. So it has given the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and that becomes 28. Now let's start the program for the prime checking, that is a number is prime or not. First we'll have to take a number, say n, and let's take an input this time. So taking input, we'll have to write it int, and we'll give the message input, and there is another bracket. Here we'll give the message enter a number. Then so it will ask a number to be inputted. Now we know a number is prime if it is only two factors, that is 1 and the number itself. If it has one factor or more than two factor, then it is not a prime. So 1 is not a prime as it has only one factor, that is 1. 3 is a prime, 2 is a prime, 5 is a prime, and 4 is not a prime because it has factor 1, 2 and 4. So it has three factors, so it is not a prime. Now let's we'll count how many factors it has. So for that we are taking a variable c, and we have initialized it with 0. Now we'll check how many factors it has. So for I in range 1, 2, n plus 1. Then if n mod I, to check whether it is divisible or not, we'll have to check the remainder. So for that we are using the modulus operator. If this is equal to 0, means I is the factor for n. So c plus equals to 1. So what will happen? C will increase by 1, and this is the shorthand operator. C plus, it means C is equal to C plus 1. That is increment operator, means a shorthand operator to increase it by 1. Now n is divisible by I, so C will be increased, and there is no other thing to check. Finally, we'll check if C is double equals to 2, means it has only two factors. Then print, then print prime, else not prime. Let's execute it. One error it is there. So enter a number. Say we have given it 5, say 6. Then enter it, not prime. Again run it, say 5, 2, it is prime.